Hi, everybody. I hope your week is off to a great start. I also hope that you've shared some good things in class. If not, please do so with someone, anyone, sometime today, or make something good happen for you or somebody else. So, let's talk today about the graph. I know you guys were pretty frustrated and the equipment wasn't the best. Um, but we'll go over what we learned or what you should have learned. I really hope that you got most of this on your own, but we're going to review just so that we're all on the same page. We're going to start with the position versus times graph. So here, you have your position and you have your time. So you're reading where you are. And the slope here tells you your velocity. This is where we get our velocity is equal to distance divided by time. If the slope is positive, then we know velocity is positive. If the slope is negative, we know that the velocity is negative. And if it's a zero slope, which is a horizontal line, then we know that there is no velocity. So that means you have stopped. It doesn't mean that you're in the zero position. It just means that you have stopped moving. So keep that in mind. So this is basic just graph reading, and I think you guys understood this pretty well, and it was at the point where the equipment was still kind of working. So these show constant velocity here. Your position is increasing with time at a constant rate. Here, your position is decreasing with time. So this one just signifies that you're moving backwards, but at a constant velocity. So what about changing velocity? How are we going to represent that? And what does changing velocity mean? That there's acceleration. So we show changing velocity in a position versus time graph by curved lines. So here you have a few graphs that show this. So the curved line means that the slope or the velocity is changing. So here you can see that you are in an amount of time you're moving, a little bit, and then as time goes by, you start moving a lot in that same time interval. So here you are going from slow to fast. So that's kind of, when you go from flat to steep, it means you're speeding up. Okay. And in this case, you have a positive velocity. Um, Again, here you are going flat to steep, but you're moving in the negative direction. So this is a negative velocity, but you're going slow to fast. So it's the same thing. Here you're going slow to fast, and it's a positive velocity, and here you are going slow to fast, but it's a negative velocity. Now remember, speeding up and slowing down is not velocity, that's just your speed. It depends on what direction you're going in that determines your velocity and whether it's positive or negative. So again, you're moving at a time interval. You're not moving much, so you're going slow. So flat is slow, and then steep is fast. So kind of think of it as like a roller coaster. So again, flat to steep is speeding up. On the other hand, when you're going steep to flat, so you're moving a lot here. So you're changing your position um, in a greater sense in the same amount of time as you are here. So this means you're going uh, fast here to slow, but this here has a negative slope, which means you have a negative velocity, and you can tell from the position that you're just moving backwards. So again, here you have a negative velocity and you're moving fast to slow. So what do you think a graph with positive velocity going fast to slow would look like? So if you're going fast to slow, so you're slowing down, so you're going to start with something steep, something like this. But if it's going to be a positive velocity, it's going to be going in the up direction. So if you can follow my cursor, it's going to go something like this and then out. So I hope that helps. But now we can relate this to acceleration. And this is what changing velocity is. So when you see a curved position versus time graph, you know that there's acceleration. But in something like this, there's velocity, but there's just no acceleration because you're at a constant velocity. So let's talk about velocity and acceleration. Now, when you're reading a velocity and time graph, here, not to state the obvious, but if it's above 0, then you have something positive. So anything above 0, you're going to have a positive velocity, no matter what the slope looks like, if it's a positive slope or a negative slope. In this case, the slope, what do you think it represents? We know that a velocity time graph, so your slope is velocity divided by time, and that is your acceleration. So the slope tells you the acceleration, but this still has a positive velocity because it's above the 0. So you have positive velocity no matter where the slope is pointing, or if it's positive or negative. On the other hand, here you have a negative velocity, and again, it doesn't matter what type of slope you have for the velocity. But obviously, if you have a positive slope, so here you have a positive acceleration. Here you have a negative acceleration, but you still have a positive velocity. So be careful with that. Read the graph. This is, you're reading a velocity graph, but it's the slope that's telling you the acceleration. So let's talk about the velocity versus time graph just a little bit more. So here you can see in this one right here, when you are speeding up. So if you are in a positive slope and a positive velocity, that means you're speeding up. So you're increasing your speed here in the positive direction, and here you're also increasing your speed. So as the numbers get higher up here, your velocity is greater in one direction, and here as you go down, your magnitude increases, but it's in the opposite direction. So as you can see in the graph, you can either go positive 9 meters per second or negative 9 meters per second, and then all the differences is in which direction. So both of these lines represent speeding up. On the other hand, over here, this is where you're slowing down. So you can think of it as the line is approaching 0, right? So as you're approaching 0 from a higher number, you're naturally getting less and less. So you're slowing down in this case. Same thing for that bottom line right here. You're starting at -9. You're still going in the opposite direction, but as you're going in the opposite direction, you're approaching 0 velocity. So if you can picture, let's say this line right here and this line right here, if you were to put them together. So if you can follow my cursor from up here, and it'll just go right through there, right through the time graph. So what do you think that means, right? So here you're slowing down, right? You're still going in the positive direction and you're slowing down, and then once you get here to a velocity 0, that means that you've stopped. But if you continue this line going this way, what does that mean? That line going this way is right here. So that means you're speeding up, but you're going into the negative direction. So what's going on here is that you are going in the positive direction and you're slowing down until you stop. And then right here at 0, you turn around and you start speeding up in the other direction. I know that's a little confusing, but take a little minute to think about it, and we'll move on. So now let's put this all together. So if I give you a graph that looks something like this right here, and it's a position versus time graph, and I want you to graph the velocity versus time and the acceleration versus time. So what we can start out with is, as you see, I've broken up into little pieces, little parts, according to how the object is moving. So this part right here, we're going from flat to steep, right? So that means that that we are speeding up, right? Flat to speed, that we are speeding up. But we're speeding up, it's a negative, right? It's a negative slope, so we're speeding up in the opposite direction. So this is our velocity. We are speeding up, if you remember, right here. This is speeding up. So we are speeding up, but in the opposite direction. So our velocity is negative. And so we go to the second part right here. this is a straight line, which means our velocity is constant. And to represent that on the graph, it's a horizontal line, right? So here's our velocity for this part right here, constant. And it's a negative slope, so it's still in the negative region of the velocity. So this part right here, we go from steep to flat, right? So steep to flat, we're still at a negative slope, so we still have a negative velocity. We're still lower here. And so from steep to flat, that means we are slowing down, right? So slowing down, when you're under the zero in velocity, it actually moves up. And so we get to this point where we start going flat to steep. So that means we're speeding up and we're changing our position, right? So here, as you go up, your position is positive. And this is the turnaround point that I was talking about right here in the middle. So you move up here, and so you continue to speed up. And then here, again, what's going on is you change your position the same in the same time interval. So that means you have a constant velocity, and this is where the horizontal line comes from. Now let's translate both of these into acceleration, right? So we know that everywhere there's a curved line, there's acceleration. Anywhere there's a straight line in the position graph, the acceleration is 0. And the reason the acceleration is 0 because the velocity is constant. So let's look at compare our position to our acceleration, right? So we know there's acceleration here. We know there's acceleration here and here, right? So this is where we have it. There's acceleration there and there. So we know that it's not 0. We're all set there. Now the straight lines here and here, we know there's no acceleration because it's a constant velocity, and so we put it 0 here. We can also compare the velocity to acceleration, right? We know here your velocity is constant, your slope is 0, so that means your acceleration is 0, right? So 0 slope means 0 acceleration. Now let's look at a spot where the slope is not 0. Let's look at this one right here. So this one, we know we are speeding up, right? But it has a negative acceleration because we are speeding up in the negative direction. So this is where the negative acceleration comes from. And it's a straight line, so we know that we are accelerating at a constant rate. This is why this is horizontal. On the other hand, we have this one right here. And if we can see from this one right here, that means we are slowing down. We're slowing down, but we're still going in the negative direction. So you're decreasing your speed and you're going in a negative direction. So it's a double negative, and that's where you get your positive acceleration here. And then you get to a 0 velocity, right? You're at 0, that means you're not moving. At this point, you have turned around, and then you continue in the other direction. So you turn around and then you go in the positive direction at the same rate that you were slowing down at down here. So here it's a straight line here, which means it is a constant acceleration and it's positive. So you're slowing down in the negative direction. So a negative times a negative is a positive, and now you're speeding up in the positive direction. So this entire line here is represented by a constant acceleration. Now keep that in mind. We'll learn about it a little bit later, that just because your velocity is 0 doesn't mean that you're not accelerating. We'll learn about that in a couple of days when we talk about falling and free fall and throwing objects. So, I mean, you can relate this backwards. You know, you have a constant acceleration that's positive, so you know what your velocity will kind of look like. So you can work in between position, velocity, and acceleration. Just make sure you know what you're reading on the graph and what the slopes mean. This is going to take some practice, and I will give it to you, but I hope you guys understand this, and I hope that this has helped. Again, I really hope that you got most of this on your own during the lab, but I know it was frustrating. So anyways, I hope it helped. If you would like to see this video again, you can have them replay it, or you can email me. My email is right on the board. I can send you the link to it, or I can send you the PowerPoint file to your email. So that is all. Now you should be getting a practice worksheet. So have a good rest of the day, make good things happen, and don't forget to celebrate them.